Introduce Dr. Radhika Kulkarni. So before I go through her formal biography, let me say this. She is one of the top leaders when it comes to data science and AI. All of us who are here know about SAS because we have used SAS in our classes or in our industry work. Every innovation that you have seen in SAS in last decade, I can tell you had Radhika's fingerprints. So all the new products SAS pulls out are based on the research and development SAS does. And Radhika was in charge or the leader of that innovation through research. So Dr. Radhika Kulkarni is a former Vice President of Research and Development at SAS Institute, and she is the President-elect of Informs. So a lot of us also know about Informs, which is a key organization in the field of analytics and operations research. Dr. Kulkarni is an advanced analytics professional, active in operations research, AI, and machine learning. And for the last 10 years of her career, Dr. Kulkarni was the Vice President of R&D at SAS, overseeing software development in many analytical areas, including stats, operations research, forecasting, data mining. She is an active member in Institute of Operations Research and Management Sciences, which is Informs. And she is the recipient of Women in Operations Research and Management Sciences WORMS Award. She was recognized as an Informs Fellow in 2014, and she currently serves as the President-elect of Informs. So what an accomplished career with so much of knowledge and depth. I think it would be great pleasure for us to learn from Radhika today about machine learning, artificial intelligence, and optimization. And she's calling out for the opportunities for interdisciplinary innovation. As we know, data science is an interdisciplinary field. So with that, I would like to invite Dr. Radhika Kulkarni for her keynote. If you want to learn more about her keynote, there is a brief description in the program today. With that, Dr. Kulkarni.
Good morning. It is a great pleasure for me to be here today and share with you some of my experiences over my career. And I would like to thank CADSCOM organization team, Dr. Bukralia, the deans, and everyone involved in this organization to have invited me for this presentation. And, as Rajiv just mentioned, this is something I'm really passionate about. So I hope I can share some of that passion with you during my talk. So what I would like to talk about today are what are the critical business problems that are driving the need for speed? Because that's where the genesis for this big explosion in AI, data science, and all of that has come about. They offer lots of opportunities for innovation, and I'll talk about some of them with examples of how we used interdisciplinary research to make these innovations. And finally, I will talk about some of the barriers to implementation and success of implementing these decision-making solutions. So with that, let me start by talking, we all hear about big data everywhere. It's become a buzzword, even in newspaper media articles. We've been hearing about that for the past decade or more. And with the advent of big data, where you can see data coming at you from all different sources, whether it be your iPhone or sensors on aircrafts and driverless cars or camera, Twitter feeds, Facebook, text data, all kinds of data is coming at you, pouring in from multiple sources. And if you want to take advantage of the value from these data sources, what is it that you need to do? So in order to do that, so essentially what we are talking about is what are the different ways in which we can get value from data. And it would be interesting to look at the different types of data sources and examine them a little bit. And you will see that the data sources can be in many different formats. For instance, at the top left-hand corner, you will see a data source which would be needed if you want to determine who are the people who are going to respond to your campaign. If you're trying to market a new iPhone or a new laptop or anything in the retail space, or offers, credit card offers, etc., you want to know who are the people that I should reach out to. For that, you need information about all the people in the population, their age, their demographic information, and many, many different attributes. So you have data that's in a rectangular format. If you want to look at past data, past history, and figure out what is the future demand going to look like, what are the future problems that you can see, what are the future sales going to look like, what is the future in any different field going to look like, you need a timestamp data to tell you what the trend is. And we've all seen timestamp data galore in the past year due to COVID. We've seen the rise and fall of cases when it plateaus, you name it. So everybody has got used to seeing the trend. And for that, you need a data source which has timestamps and will allow you to look at how the values vary over time. If you're looking at how the entire population has been changing over time, like we have all been following very carefully, what is the COVID situation in the different parts of the world, etc., you need this entire set of data over different periods of time. So, and in order to determine all of that, this is known as panel data. If you want to just look at who are the people who are influencing certain decisions, you want to look at network data, who is connected to whom, etc. If you look at Twitter data and blogs and Facebook posts, etc., you can get an idea of how our product is perceived, or what are people saying about different events happening in the world today, etc. So there you're looking at text data. You're also looking at some audio data, video data. So every data source has value that you can gain from it. But the problem is that for every different type of data source, you need a different modeling technique from the different analytics disciplines to understand it and get value from it. And that's where this notion of needing collaboration across multiple disciplines really comes to life, because unless you know the predictive modeling techniques to deal with demographic data about what's happening with campaign responses, or forecasting techniques to determine what kind of demand forecast you can have in the next few years. And all of this requires different types of techniques that you need to implement in order to get value from the data. So the question is, with all these different types of data, is it just the volume that adds value, or is it also the variety? And I claim that it's not just the legacy data sources that give you value, the data sources that you've typically used when you're analyzing some specific problem, like when you're trying to look at incidence of flu, incidence of the coronavirus, etc., you have data sources which are just the illness data, etc. But there are other data sources that will give you some additional insight, and you will gain a lot of value by incorporating those. Just looking at all the Twitter feeds and all the different people talking talking about their recent symptoms and where they've traveled, etc., you get a lot of information about the spread of the virus, for example. So adding social media and other data sources is a big value as well. Integrating text data into your analysis helps quite a bit. And something that I like talking about is incorporating network data, and I've got some examples of that in the next slide. So in all of these data sources, putting together additional data sources that you may not normally think about and adding that to your analysis is where you get additional value from all the data that exists out there. So exploiting network information is something that I like to talk about, because network data is very much something that operations researchers are used to looking at graph data and network connectivity and so on and so forth. And so some of the applications that we've used at SAS and many other software companies is to detect fraud. So if you know that a particular, for instance, daycare center or physician's site, etc., there has been some fraud, then it helps you to look at all the doctors and the daycare workers who are connected to that. And from there, you can reach out to all the connections that everybody has. And that gives you additional information that you can use to detect fraud in other places, for instance. So this is something that is very valuable. Terrorist network detection. If you know that somebody has been identified as a terrorist or a miscreant of some kind, knowing all their connections will help you focus in on those people as well, so you can detect problems faster. So targeted marketing. So if you want to market an iPhone or a particular laptop to get the maximum benefit from the release of the new product, you would like to target it to somebody who's got lots and lots of friends and connections on social media, because that means that they talk about it, so other people are interested. So that's how your product can sell better. So those are all some of the explanation, problem types that you get a lot of value by adding network information. Specifically in terms of the pandemic, because that is top of mind for all of us, contact tracing is a great example of using network connections to see who has been in touch with their social networks. And if somebody has been identified as being positive for COVID, then who are the people that are connected to him? So network data again, so which is very valuable in containing the spread of the virus. So these are all some great examples of how you can use augmented data sources to improve the value of your analysis. I like talking about this as well, where I think the whole is greater than the sum of its parts. We've heard this term very often, right? Each technology, whether it be data mining, forecasting, optimization, machine learning, each technology works well on its own, but bringing them all together is the real opportunity. For instance, when you're talking about some retail optimization problems, you need forecasting, you need to do some statistical modeling, and you need to apply some machine learning techniques and perhaps some optimization to figure out what is the best clearance prices that you need to put on your market products, etc. And of course, underlying all of it is data management, that you need to have a strong data management platform where you can put all these analytics together and you get a business solution that's targeted for specific business problems. So in that way, combining the techniques from different disciplines gives you a lot of value, which I think is very, very important for all of us to recognize. And as Dr. Bukralia mentioned at the beginning, data science is inherently a discipline or a multitude of disciplines where people recognize the value of working together. So what are the business needs that are driving this innovation in all these fields? It's the need for performance improvement. You want to drive faster. You want driverless car technology to proceed faster. You need to be able to diagnose and detect cancers faster. You want to detect the spread of the virus faster, etc. There's all these areas where you want to do quicker and quicker decisions in as innovative a fashion as possible. So another thing that's driving the need for performance improvement is the fact that you want to look at subgroups and get data and analyses from those for those subgroups, because knowing that a pocket in a particular area is more susceptible to something is very, very valuable. So you can contain the spread of COVID, for instance, in that area. So we've all seen these data per county, state, country, etc. So requiring you to build models for each of these subgroups means that you need to have the ability to automate across thousands and thousands of models so that you can pick the best model automatically. And a lot of the innovation that we did in the research and development for our software products as SaaS was in making sure that we had very, very fast algorithms that could deal with large volumes of data. And how do we make sure that our predictive modeling techniques, our forecasting techniques can all act more or less automatically as much as possible and still require some oversight from human beings. So the goal in all of this was to decrease latency at all stages of your decision process. So I think that this is a golden era for artificial intelligence, machine learning, and data science, because we have a lot of data, we have huge computing power, and we have lots of innovation happening in the algorithmic space, which is helping us make better decisions more rapidly in a highly connected world. So some of the opportunities for analytical innovation come from having to increase the scalability of existing algorithms. So we've had machine learning like neural networks and other data mining and machine learning techniques for decades. But what is different now is that you've got a lot more data, which may not even fit on one machine. So you've needed to introduce distributed computing. And in the distributed computing world, you need to enhance and innovate quite a bit in order to be able to apply machine learning techniques across distributed data. So you need to be able to scale up the existing algorithms. You need to develop new algorithms where sometimes previously intractable problems can now be solved. You need to be dealing with high frequency data, streaming data, wide data, as well as long data. So these are all the different ways in which you need a very, very rapid innovation. And it has been an exciting time for all of us in the data science and analytics field. Automation means that you need to be able to automatically tune. So when you're building thousands of models, which include all the models for the different states, counties, etc., you can't be doing it manually by applying the various machine learning techniques in a manual fashion. You need to make the computer do a lot of it automatically to pick the best model. That's called auto-tuning, automatically tuning the best parameters for your machine learning modules. That's what I mean by that. So when you're talking about microsegmentation, the complexity and the scale of this problem explodes quite a bit. Again, you might need to add some new variables, transform some new variables, and rerun the analysis. So these are all the different ways in which the number of models explodes exponentially, and being able to do them automatically is something that requires a lot of innovation, where we ended up using a lot of our optimization algorithms in local search to be able to do some of this automatic tuning, where you want to do an intelligent search in the parameter space to tune your models to find the best model for different modeling approaches, incorporating some business rules and business criteria into selecting the models. And there were lots of black box optimization methods that we were able to incorporate into our data mining, forecasting, as well as machine learning techniques. So these are some of the ways in which it was very, very exciting to see how different groups working together could innovate and create these really super fast, innovative algorithms. I'll talk about a couple of examples where we invented some new algorithms to analyze tag data where you're trying to look at temperatures, pressures, etc. Event data where there are intermittent occurrences. So some of the types of innovation that we had to do with a couple of examples which might make it more real. So we've all talked about video surveillance. We see that at airports and public places where there are videos that are monitoring the activity. And the moment they see something suspicious, an alert is sent. So what are these automatic video surveillance activities actually doing? So here is a short video which you can see running in a loop here, actually. So the original video is a video of a lobby in some reception building. And you see people walking about and they're walking around. So what we do is do some very new innovative techniques called robust principal component analysis to separate the foreground from the background. So the background is basically all the stuff that's happening in the video that is stationary, like the table, the desk, the receptionist's desk, the wall, the garbage can, etc. But then people moving around are the foreground. So now if somebody walking around has left a backpack, let's say, and after a while, it becomes stationary because the person has moved out, the backpack is not moving. So you recognize that, hey, here is something that should be an alert. And this is how, when we all hear at the airports, the announcement that if you leave your luggage somewhere unattended, it's likely to be confiscated. Because by looking at these types of videos, you can get a sense of what could be a potential danger. So here was an example where we used RPCA to be able to tease out the foreground from the background and be able to detect some anomalies. Again, this is a new example, which actually I found very fascinating. And I've included some links below where you can see more details about it. So here we are measuring the beehive health with streaming data. So the noise audio files are being recorded. So when the bees fly in and out, a healthy hive has a constant hum. And it's interesting to watch, to actually listen to the audio files, which are available in these links. And you can see how after a while, when the queen bee has left and there is no activity, really healthy activity going on, there is a change in the way the noise comes through, sorry. And so here again, monitoring beehive health uses the same types of techniques which we're using to detect the video surveillance activity as well. So again, we are separating the background noise from the foreground, and the video, we are separating extraneous flying activity from the flight of the bees. So here are some very interesting examples where we had to innovate and create some new techniques in order to be able to analyze streaming data. So in manufacturing, this is something that we've seen. Quality control is very important for obvious reasons, and especially in the high-tech manufacturing world where you're looking at wafers as they come through the manufacturing pipeline, you need to be able to detect a defect as soon as it occurs. So again, you're trying to do image analysis on streaming data so that defects are automatically detected as they move through the system. So here is an example of where you need to have streaming analytics to detect these issues that are cropping up as the wafers go through the system. In transportation, here's an example of IoT data where you're actually monitoring the train and sensors on the locomotive to see if there is some issue that's cropping up. Because when you're transporting some very, very hazardous materials across the country, you don't want an issue to crop up in the locomotive, which causes an accident, because that could spell a huge disaster. So there is more and more control being placed on the locomotives and on the railways so that they place these automatic sensors which can detect if there is a problem and stop the train if they see that there is some problem brewing in any one of the parts according to any of the sensors. So this is known as edge analytics, where you're actually placing a little bit of a control right on the machine where the stoppage needs to happen, which needs to be halted so that disaster doesn't happen as a result of the problem. So in all these places, there are different types of analytical techniques that need to get used. First and foremost, you build a predictive model based on data, historical data, all the data that you have, and that we call at-rest analytics, where you're integrating data from multiple sources and building some models. In motion analytics would be where you're looking at streaming data as it's coming through. And if there's a problem, you stop it. At edge analytics, where in the locomotive example or on oil wells, which are deep in the ocean somewhere, you might place some controls and sensors so that the moment there is a problem, you stop the functioning of that particular machine so that a huge major disaster doesn't take place. So this is the entire analytics ecosystem where you build models, you build some specialized models when you're trying to deal with streaming data, and you place the results of your models at the edge so that if there is a problem, you detect it immediately. So the analytics life cycle that we often talk about is starting with data, discover the patterns in the data and what the data is trying to tell you, and then deploy it at wherever it needs to be deployed so that you can get new insight from the data that is being generated in the future or about other related items and the population. So that is known as the analytics life cycle, but it can never stop because as newer and newer data gets generated, you might need to retrain your models so that you rebuild and update your models. So you need to be constantly monitoring to see if your modeling techniques need to be updated, if you need to incorporate new information, etc. So the analytics life cycle you can think of as something that has to be continuously happening throughout the business problem solution. So I've talked about analytics innovation. I've talked about the various ways in which you can apply analytics and the different problems which are driving the need for speed. So is it enough that you got all these fancy dancy analytics algorithms that you can apply? I don't think so. That is not enough. There are huge barriers to success. First and foremost, you need to have the right data. You need to have the right process in place. The techniques and the solutions you're proposing need to be acceptable, and you need to have the right talent. For instance, when you're looking at training data for facial recognition, it so happens that if you don't have the right data for training your models, you may miss something completely. One of my friends who is Caucasian, and she was living in China, and she was telling us the story that a lot of the models that are built there use the native population to build their models. So if somebody who's not a native of that country is seen in a video or in a photograph or something, they may not even recognize that anything is out of the ordinary because their training data did not have the right information. So they did not have the right data. So the right data is very, very important to build your models accurately. And I've included a link at the bottom here of a wonderful TED Talk where the researcher Joy, she worked with facial recognition software. And it turned out she's from Ghana, and she was, she found out that the facial recognition software did not even recognize her when it was being processed. And the reason for that is, again, the training data was insufficient. So she's done a lot of work in fighting the bias in algorithms for such situations where the data may not be sufficient to cover the entire population that you need to analyze. Do you have the right process? So even if you've implemented some excellent innovative algorithms, Unless you have executive support for making some procedural changes to implement those techniques, you may not get the value that you thought you should get. And this particular lesson is something I learned when my team was working on marketing optimization, which is basically an offer optimization problem where you have different offers that you want to make to different people, the right people at the right time to get the maximum benefit for your particular campaign that you're looking at. So there are multiple customers that you're reaching out to probably offer a new credit card offer. There are different types of offers, different types of credit card offers, different types of services that you want to offer to them. And you could be phoning them, you could be sending them an email, you could send them a letter in the mail, and all the different products that, for instance, in a bank, you could have checking accounts, mortgages, insurance, etc., etc. So this ends up being a huge mixed integer programming problem. And we put in a lot of very innovative techniques to solve this in an excellent fashion, really, really getting wonderful results. When we tried to implement it, some of the initial challenges were we had to convince the campaign managers that what we are putting in place may not benefit a particular campaign manager as much as his own algorithm that he was using, but it actually benefits the entire company or the organization. So in this particular case, you needed the executives in charge of all the campaigns to come in and make some incentives for some campaign managers who may be getting less offers to make than if they just got a budget of their own. So when you're trying to optimize a budget for a larger group, you may have suboptimal decisions at the lower levels, but you need to be able to explain to the team that here is why we are doing this, and maybe offer incentives to everybody so that they support the higher goal rather than their individual goals. So this is what I mean by needing executive support for procedural changes. So you might need to change the process by which you implement the solution. Do you have acceptable results? This is becoming extremely important, especially in machine learning algorithms, because some of them are very difficult to interpret. People using machine learning love decision trees because they are very easy to explain. You can tell exactly why this branch was chosen, this branch was not chosen, etc., etc. But when you're using some deep learning, deep neural networks and very gradient boosting types of algorithms, it's very difficult to understand why the machine took some decisions. So you need to develop some interpretable results for the data scientists or the modeler, for the consumers and users. So you need to be able to explain why my neighbor got an offer or a specific mortgage rate, whereas I did not. Everything else looks the same. What's the deal here? So you need to be able to explain to the consumers and end users. And more importantly, you also need to be able to explain it to the policymakers and regulators. You need to be able to explain why this particular way of dealing with something is better than what you've been doing so far. So these are some of the ways in which interpretability comes into play. So being able to explain the outcome is very important. Ethics and AI is another aspect of all of this, which is gaining a lot of importance in research areas where you need to, I've talked about interdisciplinarity between all the analytics researchers, but you also need to be able to work with the legal and the social policies and all of them. So now you see you're bringing in a larger group of people that need to come together in order to be able to implement your AI or analytics solution in a better fashion. So those are some of the social and acceptability constraints that come into play for a successful implementation of analytics. Do you have the right people? Of course, people are very, very important. And analytics literacy at all levels is something that I propose to everybody. So any business, any company, anybody who is trying to create an analytics team, you need to recognize that you should be able to have leaders of research groups who understand the value of analytics. They may have specialization in any one particular area, but they need to understand what the other areas bring into the picture. Why are they important? Business leaders who are making investment and hiring decisions, maybe they don't need to have a master's or even or a PhD in any analytics discipline, but they need to understand what are the types of problems that can be solved with analytics, what are the types of skills I need to hire in order to do a good job within this team. And for the analytical expertise themselves, you might need people who build the algorithms, in which case you might need somebody with a PhD in a particular statistics or optimization or forecasting area to invent new methods, invent new algorithms. Or you might need somebody who has an awareness of these tools and can understand and interpret the results so that they can use the tools that are available. Especially nowadays, there's a plethora of tools available, both commercial as well as open source, where you can apply tools automatically, but you need to be able to understand the results and apply them appropriately. You need database engineers and IT for managing the storage and updating challenges of data. And these folks also need to understand, why are the analytics folks constantly asking me for more data of this kind, more data of that kind? They need to understand what the data means. And finally, of course, you need the students and the educators to understand the potential areas of study and research so that we can build this army of people who are equipped to address the challenges of the future. The world is huge, and there are lots of problems that are out there. And in almost every area, you will find that there are problems that can be solved better, and decisions can be made better if you apply the different analytical techniques. So in order to succeed with analytics, I'll just say you need to be able to learn to work with new sources and new types of data, exploit the analytical infrastructure for large data, implement and explore new algorithms, and educate, enable, and train your workforce. So at the end of the day, what you're trying to do is using the data you want to get value with as much automated data-driven decision-making as possible. Otherwise, it'll end up being you're just drowning in data, but starving for information. So in order to get value, you need to be able to apply all of these techniques and tips that I gave you just now. And I hope that all of you are successful. This is a great time to be in the field of AI and data science. And I think there is great value that you can have by pursuing this. So I hope that you learned a little bit from this and that I've shared a little bit of my passion with you. Thank you all very much for giving me this opportunity to talk to you. And with that, I turn it over to Rajiv. And if there are any questions, I'll be glad to answer them.
Thank you, Radhika. I think we may have a chance to ask you one or two questions. So if anybody from the audience have any questions, feel free to post your question through question and answers, and we'll monitor that. While the audience is doing that, I want to ask you a question. And so creating innovation through software in a company like SAS, which is so well known in the field, what challenges did you face, particularly in the context that data science is evolving very quickly, the algorithms are evolving quickly, we are tapping into new sources of data that we never had before, the needs of the organizations are constantly changing, many times they don't know what they want. So given all of that complexity, how complex was your job in terms of the VP of R&D and creating innovation that can meet that can help achieve the goals for the organization that use SAS?
First and foremost, it was instilling in everybody the recognition that we can all work together and learn from each other was something that I was very passionate about. And when the analytics division was first formed, that was one of the goals I had, to ensure that people recognize that by working with each other, you can see problems that you may not have recognized if you were just within your own team. And solving problems in one area and talking about it with others, there is always a spark of recognition that, wait, this looks something similar to what I've done before. So maybe I can do that as well. And this technique helped in this particular problem. So maybe we can apply that as well. So that's very important. Plus, it was always a challenge to keep up with the innovation that is needed. And the biggest challenge we had was when we went from working with software, working on software that was a single machine, where all the data was on one machine, to going to distributed computing. When the data was distributed across multiple machines and multiple cores, multiple everything, then you had to really learn to use the data in a very efficient manner. So sometimes you had to ensure that your algorithm did fewer passes through the entire data, so that you could do the inter-node communication could be minimized, but still get value from everything. And many of the people that worked in the research and development specialized in their field of study, but they also needed to have an aptitude for programming and understand computing. And that is what helped with the innovation. And every one of us had to learn about the challenges of distributed computing and needed to know what it takes to build these algorithms. So those were some of the challenges. What really also helped us was the constant connection to people who are using the software. Right? Talking to customers and learning about the problems and how they're using it, that helped a lot. So it really helped us to see how people were using our software and what were the challenges they faced. So what do we need to do to overcome them? And so we learned a lot from the way that our customers applied the software we were producing. So, and then of course, building some of the targeted business solutions put more emphasis on some specific types of algorithms that we had to create, etc. So there were many different areas like that. And at the end of the day, having a leadership that is very supportive of analytics innovation really helped. And since most of you are familiar with SAS, I can say it was something that Dr. Goodnight instilled in all of us, serving the customers with their needs and innovating. And so that was some of.
So people who don't know, Dr. Goodnight, the founder of SAS, was a professor. So
yes.
as professors, we can take a big pride on that we can also create companies like SAS, that we are not totally out of touch in this world. It has been a pleasure talking with you, Dr. Kulkarni. And with that, I want to move on to the second part of our conversation, which is a panel discussion. So thank you so much, Radhika.